Okay, this is day 2 of proofs, and we are stepping things up a notch. Yesterday we looked at midpoint and bisects using those in proofs, and you'll see that the one in front of us right now doesn't have anything about midpoint, anything about bisects. I went ahead and set up the beginning, put the given information down. You'll notice that steps 2 and 4 are blank, intentionally so because we are going to try to apply our given information and draw a conclusion from it. By that, I mean make the most specific example that you can, specific conclusion. So I'm looking at my first given. I've rewritten here, and I want to know, what does complementary mean? And you're thinking in your head right now adds up to 90 degrees. All we're going to do is we're going to put that into an equation, exactly as I just said. So angle 1 plus angle 2 is equal to 90 degrees. And how did we know that? Because it said complementary, and that's my definition of complementary angles. Same thing when we get to step 3, because I've got now angle 3 and angle 4 are complementary. Rewrote that right there, and I would like to turn that into an equation. So hopefully you're thinking something like angle 3 plus angle 4 is equal to 90 degrees. It tells me they're complementary, and I'm using my definition of complementary angles. Okay, that part's the same as what we did yesterday. Both of our givens are done, as in I use them. Sometimes I like to say, let's cross them out. I'm not going to do anything else with those. Now I'm going to look to either put things together, or of course I can look at my picture and get more information from my picture. Just for the fun of it, because I already have 2 equations, I'm going to say, let's start actually by using what we already have, and I'm going to use the 2 equations that I have. I noticed that we said angle 1 plus angle 2 is equal to 90 degrees. If I look right here in step 2, and then we said in step 4 that angle 3 plus angle 4 is equal to 90 degrees. Now we said if we have 2 quantities equal to the same third quantity, and you're probably seeing that right here, 90 degrees, 90 degrees, we kind of want to cross those off, and we can then say that the 2 quantities are also equal since my 90 degrees are equal. So my new equation becomes angle 1 plus angle 2 is equal to angle 3 plus angle 4. You should be recognizing that as one of your properties. The transitive property, and I should note that that also could be the substitution property if you think of it as taking the equation that we have in step 2 and rather substituting angle 3 plus angle 4 into the 90 degrees since they're equal. So that would be an acceptable answer as well. At this point, I might want to look what I'm asked to prove. I have a really nice equation here. If we look back up at the proof, it says we're supposed to prove angle 1 is congruent to angle 4. I don't know how many more steps I'm going to need, but I do know that I'm going to need to get down here to angle 1 is congruent to or equal to angle 4. I see an angle 1 on the left-hand side. I like that. I see an angle 4 on the right-hand side, but I've got a 2 on the left and a 3 on the right. And I need to somehow get rid of those. If you're thinking along the lines of subtraction right now, I like what you're thinking, but we do have a slight problem. We're only allowed to use our subtraction property when we subtract the same thing or equal things from both sides. Do I know if angle 2 and angle 3 are equal? Well, in my proof so far, I have not said anything about angle 2 and angle 3 being equal. So I'm going to check my picture real quick. Angle 2 and angle 3. Remember, your picture is part of your given information and can be a huge help. Angle 2 and angle 3, find them in your picture. What kind of an angle pair is angle 2 and 3? You better be saying vertical. Vertical angles are congruent. We're in luck. That turns into my next step, stating that vertical angles are congruent. Allowing me to do one of 2 things. We could actually go ahead and subtract angle 2 and angle 3 because they're equal to each other. We could go ahead and subtract angle 2 from the left, angle 3 from the right to end up with step 7, angle 1 is congruent to angle 4. Okay, and that would be my ESPO. However, I'm going to show you one other way to do this that you might find a little bit clearer. A lot of people like to see subtracting the same thing from both sides. If you prefer that method, let's go ahead and rewrite the equation we have in step 5. Angle 1 plus angle 2. But instead of writing angle 3 on the left-hand side, I'm going to replace angle 3 with, what do I know angle 3 is equal to? Step 6 tells me angle 3 is equal to angle 2. So instead of putting angle 3 there, I'm going to put an angle 2. Everything else is exactly the same as you see it in step 5. Angle 1 plus angle 2 is equal to angle 2 plus angle 4. Property I just used? Substitution property. I'm taking out something, putting something in place of it. Angle 3 becomes angle 2. From here, it's a little easier to see, hey, I subtracted angle 2 from both sides, cancels there, cancels there. I'm left with angle 1 on the left, angle 4 on the right. Angle 1 is congruent to angle 4. That was what I was asked to prove. Final reason, SPO, abbreviation for subtraction property of equality. There's a quick example on using complementary. I hope you can see that we could do a very similar proof if we were given the information that two angles were supplementary instead of complementary, and supplementary here. You would have been dealing with 180 degrees, and otherwise this would have been a very similar proof as far as making equations, setting them equal to each other. Okay, step 5 was different here, and if you got stuck, I'm guessing that might have been where it was that you got stuck.